Yeah, welcome back to next topic in this final unit, fifth unit. Now we will see the pressure measurement. Pressure measurement. So pressure using diaphragm, bellows, piezoelectric, tactile sensors. So this topic will complete in this session. So pressure measurement, pressure is the force per unit area that a liquid or gas exerts on its surroundings. Units are expressed in terms of pounds per square inch psi or pounds per square foot, that is PSF in English units, or pascals in metric units, which is the force in newtons per square meter, that is Newton per meter square. So formal definitions are there are three types of pressures: absolute pressure, differential pressure, and gauge pressure. So here, absolute pressure is used for a pressure measured relative to vacuum. So relative to vacuum, the absolute pressure is measured. Differential pressure is the differences between two pressures is measured. Gauge pressure is for pressure measured relative to some fixed reference pressure, usually the atmospheric pressure. So this is the three formal pressures. So to measure this, so P gauge pressure is equal to absolute pressure minus atmospheric pressure. Vacuum pressure equal to atmospheric pressure minus absolute pressure. So this is how the pressures are related. All three pressures are related, and you can see here these two P absolute, P vacuum is equal to atmospheric pressure. So gauge pressure is more than atmospheric pressure is always, and this is absolute pressure which is measured from vacuum. So this picture gives you clear idea about these three types of pressures. Instruments for measurement: gravitation type manometers, mechanical displacement type ring balance manometer, bell type manometer, elastic pressure transducer, Bourdon tube pressure gauge, diaphragm type gauge, Bellows gauge, and electrical pressure transducers are resistance type pressure transducers, potentiometer devices, inductive type transducer, capacitive type transducer, piezoelectric pressure transducer, and Bridgman gauge. So these are the different types, and we have few more. These are the low pressure measurement gauges: McLeod gauge, thermal conductivity gauge, ionization gauge. So varying pressure measurement, engine indicator, CRO, so cathode ray oscilloscope is also used to measure pressure. So working principle is elastic deformation. So in elastic deformation, force summing devices which convert the applied pressures to displacements are primary transducers, while generating displacements may be measured by secondary transducers. The commonly used force summing devices are diaphragms, bellows, and Bourdon tubes. So these are the three we are going to discuss here. Diaphragm sensor. So here the movement of the center of a circular diaphragm as a result of pressure difference between its two sides is the basis of pressure gauge. For the measurement of absolute pressure, the opposite side of the diaphragm is a vacuum, and for the measurement of pressure difference, the pressures are connected to each side of the diaphragm. For the gauge pressure, so all types of pressures can be measured here. The pressure related to atmospheric pressure, the opposite side of the diaphragm is open to atmosphere. The amount of movement with a plain diaphragm is fairly limited. Greater movement can, however, be produced with a diaphragm with corrugations. So I will show you corrugations in diagram. So these are the corrugations. So these are the corrugations, and this is deflection. So this is diaphragm. Diaphragm, it is a elastic member, and diaphragm deflects because pressure greater on other side than this side. So here the pressure is more this side, and lesser this side. So it deflects towards the lower side. So this is the diaphragm sensor. So diaphragms of different kinds. So this is for absolute pressure measurement, and one side is vacuum, and other side pressure is measured. Whereas here the differential pressure can be measured. So both sides are open, and pressure one side one pressure and other pressure is applied on the other side. So this is corrugated diaphragm in capsule form. So this is corrugated diaphragm in capsule form. So these are the three kinds of diaphragm pressure gauges. The movement of the center of diaphragm can be monitored by some form of displacement sensor. So here it can be used as displacement sensor also. Figure shows the form that might be taken from strain gauges are used to monitor the displacement, the strain gauges being stuck to diaphragm and changing resistance as a result of diaphragm movement. Typically, such sensors are used for pressures over the range 100 kilopascal to 100 megapascal within an accuracy up to about plus or minus 0.1 percentage. So here this is used for differential. This is strain gauge. Strain gauges are attached to diaphragm to measure the deformation. So with that deformation is directly proportional to pressure measured. So next is bellows. Bellows are thin-walled cylindrical shells with deep convolutions and are sealed at one end. The sealed end suffers axial displacement when pressure is applied at open end. So here this is the bellows is used, and here it is kept, vacuum is kept for absolute measurement, and this is for differential pressure measurement. So bellows is another type of pressure measuring device, and you can retrofit to LVDT and you can measure the pressure like in next slide. So LVDT as a secondary transducer in conjunction with bellows. So bellow is attached to LVDT, and this deformation of bellow can be directly measured by LVDT. LVDT gives precise deformation measurement. So it is very much possible. And next we have piezoelectric sensor. So piezoelectric sensor here, when certain crystals are stretched or compressed, charges appear on their surfaces. This effect is called piezoelectricity. Examples of such crystals are quartz, tourmaline, and zirconate, titanate. A piezoelectric pressure gauge consists essentially of a diaphragm which presses against a piezoelectric crystal. So the crystal is pressed here with the compression movement. The movement of the diaphragm causes the crystal to be compressed, and so charges produced on its surface. So piezoelectric crystal produces charges, and the crystal can be considered to be a capacitor which becomes charged as a result of diaphragm movement, and so as a potential difference appears across it. So the potential difference can be measured from the crystal. The amount of charge EMF produced, and hence the potential difference depends on the extent to which the crystal is compressed along the specific axis, and hence is a measure of the displacement of the diaphragm, and so the pressure difference between the two sides of the diaphragm. So the if the pressure keeps the diaphragm at a particular displacement, the resulting electrical charge is not maintained but leaks away. Thus the sensor is not suitable for static pressure measurements. So for static pressure measurements it is not suitable. Typically such a sensor can be used for pressures up to about 1000 megapascal with a non-linearity error of about plus or minus 1 percentage of the full range value. So this is the sensor piezoelectric, and if you see, this is the quartz. Piezoelectric crystals can be lead, zirconate, barium, titanate, quartz. So piezoelectric crystal is placed and against this diaphragm, and when diaphragm deforms, it compresses the crystal and it produces the electrical charges. So there ends the pressure measurement, and same books you can refer, and also you can measure, you can refer AK Ghosh. It is a very good book to refer for this topic. Thank you, students. So we will meet again in next session. We will start another topic in next session. Thank you.